Today I'm going to introduce you to the product rule. So when we have two functions that we are multiplying, we're going to have a rule for the derivative. But first, let's kind of explore what this rule is going to be. So we're going to have two functions, g of x, which is x to the 7th, and h of x, which is x to the 11th. F of x is going to equal g of x times h of x. So the first thing we're going to do is find each of the derivatives individually. So if g of x is x to the 7th, g prime is going to be 7x to the 6th. And then if h of x is 11x, then h prime is going to be 11x to the 10th. Okay, so now we're going to write f of x as a single power. So f of x is equal to g of x times h of x. So that's going to be x to the 7th times x to the 11th, which is going to be x to the 18th when we add those exponents. So that's what f of x is equal to when I multiply those two functions together. So the derivative of f is 18x to the 17. Okay, that is the derivative of the product of those two values. Okay, what we're going to look at is, you might think, because a lot of our rules say like, well, the derivative of a sum is equal to the sum of the derivatives. What we're looking for is that true with products? So let's multiply g prime times h prime and see if we get the same thing as we have here. So that means I'm multiplying 7x to the 6th times 11x to the 10th. So 7 times 11 is 77, and then x to the 6th times x to the 10 would be x to the 16th. So these two things are, there's our bell again. These two things are not the same. Okay, this does not equal.
Good morning, Lewis Palmer. Please stand for.
This and this are not equal, so this does not equal the derivative. So our goal here is to come up with, how do we use these pieces to come up with the 18x to the 17th? So it says it is possible to get the correct answer for f prime using a clever combination of g of x, h of x, g prime of x, and h prime of x. For instance, you'll notice that the 18 is the sum of 7 and 11 in the derivatives. So we're going to come up with a way to use those four things to end up with 18x to the 17. Okay, so the 18, we said, well, if I add those two together, I get 18. So I'm going to have 7x to the 6th, and I'm going to leave a space, plus an 11x to the 10. So I will get an 18 if I can make it so that I can add these together. Right now with the different powers, I can't. So if I need this to add up to be x to the 17, what would I need to multiply x to the 6 by to get x to the 17? Well, we need to multiply by x to the 11th. And then here, I need to multiply by x to the 7th. Well, those happen to be f of x and h of x. So what this derivative ended up being, 7x to the 6th is g prime of x. X to the 11th was h of x. 11x to the 10th is h prime of x. And x to the 7th was g of x. So the product rule looks like this. So the conjecture, which is not going to be just a conjecture, it's going to be what it is. Sorry. F prime of x is going to be this. G prime of x, h of x, plus h prime of x, g of x. So it's the derivative of one times the other plus the derivative of the other times this. Okay, so we're going to add to our list of derivatives. So you should have note cards. I will add to this list the chain rule that we've been talking about for the last couple days. So f prime g of x times g prime of x. Okay, and now we're going to add the product rule. I'm going to write this in two different ways, and you choose which one makes the most sense for you. So first I'm just going to do it u v prime. So we have two functions, the derivative. So this is going to be u prime v plus v prime u. Okay, we can also write this using our function notation. So f of x times g of x, the derivative, is equal to f prime of x, g of x, plus g prime of x, f of x. Now the order here is pretty forgiven. We're multiplying here. So if you do g times f prime or f prime times g, that's fine. If you do this one first because we're adding. So the order doesn't really matter. It's just the derivative of one times the other not derivative, and then the other one derivative times that one. Okay, so it says assume that your conjecture is true of any product. So we're going to do the derivative of x squared times sine of x. So that's going to be x squared prime times sine of x plus the derivative of sine of x times x squared. So here's the derivatives, here's the not derivatives. So this would be 2x sine x plus cosine of x times x squared. When you're on your own, when you're in your homework and you're not sure if you found the correct derivative, you can check it using the graphing feature on your calculator. So what we're going to do is I'm going to graph my function. So x squared sine x. I'm going to graph the derivative. So remember, this is alpha f2 derivative. So I'm going to graph the derivative of y1, so alpha f4, when x equals x. So you can always check your work doing this, because now I'm going to plug in what we got here. So 2x sine x plus cosine of x times x squared. Now I really don't care about this first graph. It's there so I can have something. If I graph, and always in radians, always in radians. If I graph, so this one is the derivative that the calculator came up with. And if we are correct in our derivative, the next graph should match this one. And it's going over. You can see the red is turning black, which means that we have the correct derivative. So if you're not sure if you have the correct way, you can graph your function, the derivative, and then what you think the derivative is. And if these are the same, then you're good to go. All right, so let's just power through some examples. So this is a product. So f prime of x is going to equal the derivative of x cubed times sine 2x plus the derivative of sine 2x times x cubed. So now we'll do the derivatives. 3x squared times sine 2x plus the derivative of sine 2x, which is going to be cosine of x, cosine 2x times 2, chain rule still applies, x cubed. And again, you can simplify this, or we're just going to leave it like this. So we're going to have 8x prime times 3x plus 7 to the 9th plus 3x plus 7 to the 9th, that derivative, times x to the 8th. Then we'll do our two derivatives. So we're going to have 8x to the 7th, 3x plus 7 to the 9th, plus 9, 3x plus 7 to the 8th, times the derivative of the inside, so chain rule, chain rule, chain rule, times 3, x to the 8th. Here, I'm going to show you, some of you might see, oh, that's 4 times cosine. The constant's just going to go along for the ride, so you don't have to use the product rule here to do this derivative. But you can and you will get the same result. So let me prove that. If I apply the product rule here, we're going to have the derivative of 4 times cosine of x cubed plus the derivative of cosine x cubed prime times 4. Well, the derivative of 4 is 0. This derivative, we're going to have a negative sine x cubed times the derivative of the inside, 3x squared, times 4. So this one's result is going to be a negative 4, well, actually negative 12, positive. No. Negative 12, because 3 times 4, x squared sine x cubed. You can leave it like this, but this piece goes away. So you can just do this derivative and multiply it by 4, and you have the right thing. Okay. Here we have the product of cosine and sine, 3x. So this is going to be the derivative of cosine times sine 3x plus the derivative of sine 3x cosine of x. Derivative of cosine is a negative sine. And then here, we're going to have a negative cosine 3x times 3 cosine of x. And again, you can clean that up a little bit if you want to, but you don't need to. Okay, look at this next one. These two look very, very, very similar, but this one is cosine x times sine of x. This is cosine of sine 3x. So this one is a product. This one is the chain rule. Okay, so if I do this derivative, start on the outside and just work our way in. So the derivative of cosine is negative sine, then we leave the inside alone, times the derivative of the inside, which is going to be cosine 3x, times the derivative of that inside, which is 3. All right, this one has 3 functions we're multiplying together. So we have 3 things to deal with. So this derivative, we're going to take, there's going to be 3 parts. And we're going to take the derivative of one of them within each part. So I'm going to do, so I'm going to have 4x to the 6th prime times sine cubed x cosine 5x plus 4x to the 6th sine cubed x prime cosine 5x plus 4x to the 6th sine cubed x times the derivative of cosine. So we have 3 parts, and we're going to do 1 derivative on each. So this is going to be 24x to the 5th times those 2x plus 4x to the 6th times the derivative of this. Remember, sine cubed x is the sine of x cubed, so we need to use the chain rule here. So this is going to be 3 sine squared x times the derivative of sine of x times this. That goes along for the right, and then we have 1 more derivative. So this is going to be a negative sine 5x times 5. In the notes online, you can see a proof of why this works. But if you have 3 of them, you just do 1 derivative. Okay, so we're going to find the derivative of this 3 ways, just to show you that you can find the same solution through different methods. And as you're going through, you'll all see them differently. There's 2 things that we're going to need for this, and they are 2 trig identities. The first is that cosine 2x is equal to cosine squared x minus sine squared x. Okay, and we did these in pre-calc. The other one we're going to need is that sine 2x is equal to 2 sine x cosine x. Okay, so using the trig identity, if f of x is equal to cosine squared minus sine squared, that means cosine of x can be rewritten as cosine 2x using that identity. So then f prime of x is going to be the derivative of cosine 2x is going to be a negative 2 sine 2x. Okay, using the chain rule. Okay, chain rule, we're looking at cosine of x squared minus sine of x squared. So using the chain rule, this is going to be 2 cosine of x times the derivative of cosine of x minus 2 sine x times the derivative of sine. So when I simplify this, we're going to have a negative 2 sine x cosine x minus sine x cosine x. So this is going to be a negative 4 sine of x times cosine of x. And you can simplify that down in your steps. So is this the same? Well, yeah, here sine 2x is equal to 2 sine x cosine x. So this would actually equal negative 4 sine x cosine of x. Okay, and then we're going to do this using the chain rule or product rule. So I'm going to do, rather than cosine squared, I'm just going to multiply cosine of x times cosine of x minus sine of x sine of x, and use the product rule. And we're going to do 2 products. Okay, we're going to do this one derivative as a product and this one as a product. Okay, so product rule here, I'm going to have cosine x prime cosine of x plus cosine of x prime cosine of x. This one, we're going to subtract sine x prime sine x plus sine x prime sine x. So just applying those 2 product rule here, product rule here. So the derivative of cosine is a negative sine Same here. Minus derivative of sine is cosine of x. Okay, plus. So when I distribute this through, this is minus, and I have a sine cosine, sine cosine, sine cosine, sine cosine. So I end up with 4 negative sine x cosine x. Okay, so obviously this is probably not the ideal way to do this one. That's probably the hardest. Probably the chain rule would be the easiest, but the point is that you can do these in different ways. All right, speaking of trig identities, what is cosine squared plus sine squared equal? 1. So f of x, even though it's written all like this is really just the function 1. So what is the derivative of 1? 0. So be on the lookout for trig identities, because they're going to, hopefully, make your life easier. All right, so we're going to find this derivative. So we're going to have the derivative of 5x minus 7 to the 4th times 2x plus 3 to the 5th prime times the first one. Okay, and then we'll just take those derivatives. So our function is going to be 4 times 5x minus 7 cubed times the derivative of the inside and we'll do this derivative, so 5 times 2x plus 3 to the 4th times the derivative of the inside times our other function there. So this is our derivative. I am going to clean it up a little bit because we are going to have some follow-up questions. So 4 times 5 is 20. 5x minus 7 cubed. 2x plus 3 to the 5th. Here I have 10. 2x plus 3 to the 4th times 5x minus 7 also to the 4th. Okay. To find the critical points. Critical points are where the derivative is equal to 0 or undefined, and this is gonna be a big thing in the next unit. To do that, I need to simplify this. Okay, so what I'm going to do is I'm going to factor the greatest common factor I can out of everything. So looking at my coefficients, I have a 20 and a 10, so I can pull out a 10. Here, sorry, these two guys, I have the same base, this one to the 4th and this one cubed. So I can pull out a 5x minus 7 cubed out of both of these. And then here, I have this cubed and this to the 4th. No, that's to the 5th. So I can pull out 2x plus 3 to the 4th. Let's look at what was left behind. So if I pull a 10 out of here, I have a 2. I pulled that whole thing out. Here we're left with 2x plus 3. Plus, I pulled the whole 10 out. We pulled that whole thing out. We pulled 3 of those. So that leaves me with 5x minus 7. Okay, so on the inside here, I'm going to distribute and simplify. So 2 times 2x is 4, plus 5 is 9x. 2 times 3 is 6, minus 7 is negative 1. So I want to know where this equals 0. So it's when each of these factors equals 0, the whole thing's 0. So when 5x minus 7 equals 0, well, that's going to be when x equals 7/5. It's going to be when 2x plus 3 equals 0. I need that. Which is going to be when x equals negative 3/2. And it's going to be when 9x minus 1 equals 0, which is going to be when x equals 1/9. So we're going to graph this on this window and look at what is happening at those three locations. Okay, so here's the graph of f of x. So we've got our 5x minus 7 to the 4th, 2x plus 3 to the 5th. So what's happening at those three locations? So at negative 3/2, we're here, that slope is 0. At 1/9, we're up there, that slope is 0. And then at 7/5, that slope is 0. So true or false? The graph of f of x has a maximum or minimum when the derivative equals 0. And it's a maximum here, it's a minimum here, but there the slope is 0, but it is not a maximum or a minimum. So that's a point of inflection. So this would be false. Okay. In a variation of a Filipino pole dance, two pairs of bamboo poles are moved back and forth at floor level. The dancer steps into and out of the region between them as they come together. The area, length times width, varies with time, where the distances are in feet and the time is in seconds. So we're going to write dA dt in terms of L and W and dL dt and dW dt. So if A equals LW, this is going to be dA dt is going to be the derivative of L, so that's going to be dL dt times W plus dW dt times L. This one, when W is 2 plus 2 cosine and L is 3 plus sine 2, at what rate is the area changing when t equals 4 seconds? So we need four things for this. We need W and L when t is 4, and we need dL dt and dW dt when t is 4. So this is not going to be a whole number. So I'm just going to let the calculator do this. So dA dt when t equals 4 is going to equal the derivative of this at 4. So the derivative is going to be 0 plus 4 cosine 2t. Oh, not t, at 4. Hang on. Sorry. Let's do each of these derivatives, then we'll put it all together. So this derivative is going to be 1 negative 2 cosine t. This derivative is going to be 0. This is going to be a 2 cosine 2t times 2 for the chain rule. So my dA dt evaluated when t equals 4, we're going to have dL dt, which is now going to be 4 cosine 2 times 4. My W is going to be 2 plus 2 cosine 4 plus dW evaluated at 4 plus L evaluated at 4. Okay, so you're just gonna dump all of that into the calculator, and you get approximately, always radians, 7.133 feet squared per second, because we're talking about an area and how it is changing. And then you can plug in 5 for the next one to get that. Okay, so an equation of the line tangent to this graph at this point. So when we do this, we need to find the slope. The slope is going to be the derivative, and so we're going to find the derivative of this. So f prime of x is going to equal x prime 1 plus 2x cubed plus 1 plus 2x cubed times x. So that's a 1 prime. This one's going to be 3 times 1 plus 2x squared times 2 times x. And then we're just going to plug in 1. So f prime of 1 is going to be 1 plus 2 times 1 cubed plus 3 times 1 plus 2 times 1 squared times 2 times 1. So this is going to be, oops, that's a minus. That's a minus. That's a minus. So this is a negative 1 cubed plus 3 times I messed up again. So these are all minuses. I apologize. So you can look in the notes for the better version. All of this ends up being with a minus. You get negative 7. So using the product rule, just copy down the questions correctly. So we have a negative 7. So the only one that has that slope is A, so that's going to be our answer.